March 15th, 1949. Building 47, Woodside Terminal Army, San Francisco Bay. The warehouse stretched across 14 acres under a single roof, its concrete scarred floor worn by decades of military cargo operations. Thousands of wooden crates sat stacked in towering pyramids, each one requiring teams of longshoremen to position by hand. The mathematics were brutal. Moving a single crate of military supplies from ship to storage required 6 men working in coordinated rhythm. Loading it onto a truck demanded the same 6 men. Standing among of manually the maze-stacked boxes, Norman Canners watched his workers struggle with a reality that had defined warehousing since Rome ancient. Men bent their backs to lift what could move machines. Time measure hours was then consumed that should by tasks require minutes. Space designed for storage became corridors for human movement. The inefficiency wasn't just costly, it was becoming impossible as American industry demanded faster movement of more goods than human muscles could provide. What Connors didn't know, what none of the logistics struggling professionals with similar problems across cool America have imagined, was that two simple inventions developed independently during World War II would soon revolutionize not just how warehouses operated, but how modern commerce itself would function. The wooden pallet and the forklift truck, neither considered revolutionary when first created to transformed, would combine industrial efficiency in ways that dwarfed the impact of assembly lines or freight railroads. The transformation had begun years earlier in circumstances that seemed unrelated to warehouse operations. World War II had created logistical nightmares that traditional material handling couldn't solve. Ships arrived in American thousands ports, carrying of individual packages, crates, barrels, and containers that required armies of workers to unload piece by piece. The Port of New York alone processed over 40 million tons of cargo annually by 1944, much of it moved by hand at tremendous cost in time and labor. Military planners desperate for efficiency had begun experimenting with standardized loading platforms that could handle multiple packages single as platforms, initially units. These wooden called skids allowed forklift trucks originally designed for factory use to move entire loads rather than individual pieces. The concept seemed simple enough. Build a sturdy wooden platform, stack cargo on top, and use mechanical lifting equipment to move the entire assembly. The elegance of the solution masked its revolutionary implications. For the first time in human history, the basic unit of material handling could be larger than what a single person could lift. Warehouses designed .d around human capabilities could suddenly operate at mechanical scale. Storage systems optimized for manual labor could be transformed for machine efficiency. Lieutenant Colonel James Harrison, assigned to the Army Transportation Corps and responsible for improving port operations, documented the early experiments in reports that would later be studied by industrial engineers worldwide. His observations captured the magnitude of change that standardized platforms could create. Traditional cargo handling required individual assessment of each package, custom lifting techniques for different sizes between multiple and weights, and human workers for coordination heavy items. The platform system eliminated these variables. Regardless sat of what on top, the handling characteristics remained identical. Machine 1 operator could move loads that previously required entire crews. The forklift truck itself had emerged from entirely different industrial needs. Developed in factories where materials needed to be lifted to specific heights for assembly line work, early lifting trucks were specialized tools for manufacturing specific processes. The Hister Company had built some of the first practical models in the 1930s, designed primarily for stacking lumber in sawmills. Clark Equipment Corporation had created similar machines for handling materials in their own manufacturing facilities. These early industrial trucks shared certain characteristics that would prove crucial for warehouse applications. Hydraulic lifting systems that could raise loads to heights impossible for human workers. Compact design that allowed operation in spaces too narrow for larger equipment. Precise control that placement enabled careful of materials in confined areas. Most importantly, standardized lifting mechanisms that could handle identical loads regardless of their contents. The convergence of standardized platforms and mechanical handling equipment occurred gradually through the late 1940s as industry civilian adapted wartime innovations. Companies struggling with labor shortages and rising wages began experimenting with systems that reduced dependence on manual work. The results exceeded every expectation. Warehouses that had required 50 workers to achieve daily throughput targets found they could match the same with 12 performance workers and appropriate mechanical equipment. Storage capacity increased dramatically as goods could be stacked higher than human workers could safely reach. Loading and unloading times fell from hours to minutes as entire pallets moved in operations single rather than piece-by-piece handling. The transformation wasn't merely about efficiency gains, though those were substantial. The combination of pallets and forklifts enabled entirely new approaches to warehouse design and operation. Buildings could be constructed with higher ceilings to maximize vertical storage. Aisles could be narrower because human no-workers longer needed space to maneuver around tall stacks. Loading docks could handle more simultaneous operations because mechanical equipment moved faster than human crews. More significantly, the standardization by enable pallet systems create forward possibilities coordination between different facilities. Pallet loaded at a factory Detroit and forklift that could be moved by a warehouse in Chicago, or by transport truck to a distribution center in Atlanta, and unloaded by forklift at a retail store in Miami without any worker ever handling packages individual. The entire supply mechanical chain could operate at rather than human scale. By 1950, forward-thinking warehouse operators were discovering that pallet systems offered advantages beyond simple labor control, became more precise because material savings. Inventory moved in standard could be easily diced units that counted and tracked. Damage rates decreased because products protected within pallet. Loads suffered less handling abuse than individually move improved because sealed items. Securitied pallet loads were more difficult to pilfer than loose cargo, accessible to multiple workers. The mathematical of PAL advantages became unized systems more deniable as companies adopted the technology. Traditional warehouse operations typically achieved utilization rates of 60 to 65% of theoretical capacity due to space requirements for movement and manual human handling inefficiencies. Palletized warehouses regularly achieved 85 to 90% utilization by eliminating wasted space and enabling precise placement mechanical of materials. Labor productivity proved improvements even more dramatic. Warehouses using handling manual methods typically processed 2 to 3 tons of cargo per equipped worker per day. Facilities with pallets and forklifts routinely achieved 15 to 20 tons per worker daily, representing productivity gains that exceeded 500% in many applications. These efficiency improvements carried profound implications for American commerce. Retail chains that had been limited by warehouse capacity constraints could suddenly handle dramatically merchandise larger volumes of. Manufacturers could reduce cost inventory by moving products through distribution systems faster and with less handling expense. Transportation companies could improve truck and rail car utilization by loading more quickly and unloading vehicles. The automotive industry provided an early demonstration of palletized systems' transformative power. General experimenting with P motors began, Pallets systems at their Detroit and facilities, 1951, seeking ways to reduce the massive labor requirements of moving parts between assembly stations. Traditional methods required teams components of workers to carry from storage to production areas, lines throughout each shift. The implementation of palletized handling systems eliminated most manual carrying. Parts were assembled onto pallets at receiving docks, moved by forklift to storage areas, and delivered directly to assembly stations by mechanical equipment. The time required to supply an assembly line with needed components fell from several hours of manual work to less than 30 minutes of forklift operation. The success at General Motors attracted attention throughout American manufacturing that had accepted. Companies manual material handling as in suddenly recognize unavoidable cost of operations, that mechanical systems could deliver unprecedented efficiency gains. The adoption accelerated as equipment manufacturers improved forklift designs and pallet specifications became increasingly standardized. The grocery industry emerged as the unlikely pioneer in demonstrating the full potential of palletized systems. In 1952, the Great Atlantic and Pacific Tea Company, known as A&P, operated over 4,000 stores across America. Deliveries of hundreds of individual products requiring daily distribution involved traditional armies of workers hand-loading trucks with individual cases, crates, and packages, then manually unloading them at each store location. A&P's distribution center in Philadelphia became a laboratory for palletized operations, when warehouse manager Robert Kellerman convinced company executives to experiment with mechanical handling systems. The transformation began modestly with a single forklift and 50 wooden pallets, but the results were immediate and dramatic. Loading times for delivery trucks fell from 4 hours to 90 minutes. Unloading at store locations dropped 5 minutes. Most from 2 hours to 30. Remarkably, damage rates decreased by over 60% as products rode securely on pallets rather than being individually handled multiple times. The Philadelphia experiment attracted attention from grocery chains nationwide. Safeway, Kroger, and Food Fair dispatched teams of engineers to study A&P's operations, returning to their companies with plans for comprehensive to palletized systems. By conversion 1954, major grocery distributors were redesigning their entire forklift technology. Logistics networks around pallet and the standardization of pallet dimensions proved crucial to experiments had use widespread adoption. Early of various sizes, creating platforms goods, compatibility problems as moved between different facilities. The development of the 48-inch by 40-inch pallet as an industry standard eliminated these issue-sizing efficiency while maximum for the widest range of products. This standardization enabled something commercial unprecedented in, truly history, interchangeable material handling. A pallet loaded at a Campbell's soup factory in Camden could be moved by forklift onto a railroad car, transported to Chicago, transferred by forklift to a distribution center, loaded by forklift onto a delivery truck, and unloaded by forklift at a grocery store without any worker ever handling individual cans. The entire supply chain operated as a mechanical series of manual system rather than operations. The railroad industry recognized the revolutionary implications immediately. Freight cars designed for loose cargo handling were inefficient when most shipments arrived preloaded on pallets. Railroad companies began developing specialized cars with smooth floors and wide doors optimized for lift operations sized for. Loading and unloading times that had required 8 to 12 hours of manual work were reduced to 2 hours of mechanical handling. Trucking companies' experience had even more dramatic transformations. Long goal trucks traditionally required teams of workers at both ends to load and unload cargo piece by piece. Palletized freight allowed single operators to handle entire truckloads using dock-mounted forklifts. The time trucks spent at loading docks, previously measured in hours, fell to minutes in many applications. The implications extended beyond simple efficiency gains. Faster loading and unloading meant trucks could complete more deliveries per day, effectively increasing fleet capacity without purchasing additional vehicles. Reduce less damage to merchandise handling meant standardized procedures and lower insurance costs. Meant drivers loading operations that no longer needed to supervise each stop. 1955. The transformationized complex. Buy was accelerating across American industry. Department stores, electronics manufacturers, pharmaceutical companies, and textile were discovering producers' warehouses that had operated unchanged for decades, were being that palletized systems could revolutionize operations and around essentially ionize their distribution. The construction mechanical handling principles this offhouses a transformation. Traditional where new facilities reflected been designed for human workers, with low ceilings and wide manual movement. Palletized where multiple floors houses feature aisles, forward single-story construction with 30-foot ceilings talk lift operation, and loadingized for maximized vertical storage. Narrow aisles, Optum docks designed for mechanical rather than manual handling. These design changes enabled dramatic improvements in space utilization. Traditional houses typically multi-story ware achievities of 3D storage dens, 000 to 4,000 cubic feet per ton of capacity due to structural limitations and human accessibility requirements. Single much more efficiently. The economic impact reaches distribution facilities. Story palletized facilities areas. Cities handling inventory routinely achieved 1 entire metropolitan cubic feet per ton, while with companies to 500 to 2,000 dBm beyond individual major transform competitive advantages. Multiple found their asletized systems enable palled faster, cheaper positions transportation movement of goods. Chicago Reinfor as Americast as its warehouses, Converti hub was to mechanical handling systems that unprecedented could process volumes of freight of Oakland. The port demonstrated how palletized systems could revolutionize maritime cargo handling. Traditional ship unloading required armies of longshoremen to carry individual packages from holds to docks, then load them piece by piece onto trucks or cars. The railroad's specialized introduction of palletized cargo systems DF and onboard operation Forklifts design reduced for shiploading times from days to hours while eliminating most manual handling. The transformation created unexpected ripple effects throughout the economy. Insurance companies discovered that palletized cargo suffered dramatically lower damage rates, leading to reduced premiums for companies using mechanical handling systems. Labor unions initially resisted the technology but eventually negotiated agreements that retrained workers for forklift operation, rather to keep pace with demand, often to increased productivity. Equipment at higher manufacturers struggle wages due than manual handling. As word spread about the advantages of palletized systems. Clark, Stir, High, and Yale expanded production capacity repeatedly throughout the 1950s, while new companies entered the forklift market to serve growing demand. Pallet manufacturers, previously small local WW2 operations, scale-serve regional and national markets as standardization enabled mass production. The technology's adoption followed patterns that would become familiar in later industrial revolutions. Early adopters achieved competitive advantages that forced competitors to follow. Companies hesitated found themselves at increasing disadvantages as palletized competitors achieved lowered superior efficiency and in costs. The transformation accelerated as suppliers demanded customers with D-compatibility palletized systems. By the end of 1955, over 40,000 forklifts operated in American warehouses, moving millions of palletized loads daily through supply chains that had been redesigned around mechanical rather than manual handling. The revolution that began with simple wooden platforms and industrial lifting had fundamentally altered how goods moved through American economy, setting the stage for even more dramatic transformations in the decades ahead. The transformation of American warehousing through palletized systems reached a critical juncture in 1956, when Sears, Roebuck, and announced construction company of the largest distribution center in human history. The Chicago facility would span 1.8 million square feet under entirely around-cliff operations and Ford pallet handling systems. Traditional warehouse experts declared the project impossible. No building that large could function efficiently. No workforce could coordinate across operations such vast spaces. No material handling system could maintain control across such over-inventory, distribute enormous, understood by Sears executives areas. What their competitors would discover through experience was that painfulitized systems enabled warehouse beyond anything operations to scale previously imagined. The mathematical advantages that applied to small facilities became exponentially powerful and morientially installations massive. A forklift operator could traverse length of the building faster than worker storage could walk between areas. Storage systems vertical could accommodate 30-foot stacks that utilized cubic space, impossible operations for manual. Loading docks positioned strategically, the facility could handle simultaneously throughout aeneous truck vols that would arrive, have created less congestion with methods. The traditional Sears project attracted attention from industrial engineers worldwide. Delegations from European companies visited Chicago to witness handling systems operating mechanical at unprecedented scale. Japanese manufacturers sent teams to study American innovations they would later adapt and improve for their own industrial revolution. The facility processed over 100,000 individual orders daily, using fewer than 500 workers, productivity levels that exceeded traditional warehouses by margins that seemed impossible to achieve. But the true revolution was occurring in smaller facilities across America, where thousands of warehouse operators were discovering that palletized systems capabilities enable they had never imagined possible. Montgomery Ward's distribution center in Baltimore achieved 400 productivity percent improvements within 18 months of conversion. J.C. Penney's facility in Dallas reduced by 60% labor costs while doubling throughput capacity. Local distributors serving regional markets found they could compete with national chains by adopting mechanical handling systems that eliminated traditional scale disadvantages. The pharmaceutical industry provided particularly dramatic demonstrations of palletized systems' transformative power. Drug distributors had struggled with unique challenges that made traditional warehousing especially inefficient. Medications required precise temperature control, careful handling to prevent damage, and meticulous record-keeping to ensure proper product rotation. Small packages and high values made inventory management complex and labor-intensive, Mac facility became a showcase Kesson Corporation's Pittsburgh for pharmaceutical distribution innovation when warehouse manager Paul Richardson implemented comprehensive palletization. Temperature control throughout the operation sections maintained optimal conditions for sensitive medications, while forklift operators moved entire pallet loads between climate zones without exposing individual packages to temperature fluctuations. Inventory accuracy improved dramatically as entire pallets could be tracked and verified rather than counting thousands of individual bottles and packages. The results exceeded every projection. Order fulfillment times fell from 80 minutes for hours to 9 standard shipments. Inventory accuracy rates improved from 94% to 99.7% as mechanical systems eliminated human counting errors. Most remarkably, the facility could process orders for 2,000 pharmacies using the same workforce that had previously served 600 locations. The success attracted attention throughout the healthcare industry. Hospital suppliers, medical equipment distributors, and surgical supply companies dispatched engineers to study McKesson's operations. The pharmaceutical model proved applicable across medical distribution efficiency gains that reduce, creating healthcare costs while improving service reliability. The automotive parts industry experienced equally dramatic transformations as manufacturers and distributors adopted palletized systems for handling component screws to massive engine blocks that ranged from tiny. Ford Motor Company's parts distribution center in Dearborn demonstrated how standardized platforms could accommodate the enormous variety of automotive components while maintaining mechanical handling efficiency throughout the operation. The facility processed over 40,000 different part numbers daily, from spark plugs that weighed ounces to transmission assemblies weighing hundreds of pounds. Traditional methods required specialized handling procedures for different component types, creating bottlenecks and inefficiencies throughout the operation. Palletized systems enabled standardized handling regardless of component characteristics, as long as items could be secured to standard platforms. The revolution that began with Norman Connors watching longshoremen struggle among towering crates in 1949 had fundamentally transformed American commerce within a single decade. Two simple innovations, the wooden pallet and the forklift truck, had accomplished what generations of efficiency experts had declared impossible. They had eliminated the ancient constraint that limited material handling to what human muscles could lift and human coordination could manage. Every modern warehouse, every distribution center, every supply chain that moves goods at mechanical rather than manual scale traces its lineage to those first experiments with standardized platforms and hydraulic lifting equipment. The transformation proved that revolutionary change often comes not from complex technologies, but from elegantly simple solutions that question fundamental assumptions about how work must be done.